didn't get this in geometry. It's x squared plus y squared equals 1. You guys ever see that before?
No.
Okay, and that's when the center is at 0, 0. Pardon me? Oh, we did it with conic sections. We used it with conic sections, remember? Or did you guys all blank conic sections out of your mind? Are they gone? Radius equals 1.
Oh, yeah.
Is that this final or was that
Last final. It's not on this final. Okay. Quadrant angle is an angle in standard position whose terminal side lies on the axis. I haven't seen quite yet where we use quadrant angle, but it's in there, so I wrote it down. So I guess that would be a 90-degree angle or a 180-degree angle or a 270-degree angle. The terminal side lies on an axis. Standard position means it starts here where x is positive. Okay? It's awfully fast. All right. All right, so we're going to learn some stuff here on the unit circle. Let theta be an angle in standard position, and let xy, that's this point right here, be the point where the terminal side of theta intersects with the unit circle. X squared plus y squared equals r squared. The 6 trig functions of theta are defined as followed. You've already seen these. Now, actually the definition here, standard position, means an angle that goes like that. That's theta. Okay? But I just wrote it here. So, the 6 trig functions of theta are defined as followed. You already know what they are. If you look at this right here, we're just considering this part because when we write a trig function, we have to have a right triangle. Correct? Okay, so we just consider this part right here. So sine from theta would be what over what? Opposite over hypotenuse, which would be what letters? Y over R. Okay? From this angle right here. And then we can just easily do cosecant, which is what? The reciprocal of this, R over Y. The cosine from theta is adjacent over hypotenuse, so it would be what letters?
X over R.
Correct. And then the secant is the reciprocal, so it's R over X. And then tangent is opposite over adjacent, which would be what? And then the cotangent is X over Y. Okay? You've seen those, and we're going to work more with those today. Alrighty, let's have some fun. You ready?
I'm ready.
Let -9, -40 be a point on the terminal side of angle theta in standard position. Evaluate the 6 trig functions of theta. Well, the only way I can do this is draw a picture. So, I'm going to draw an x-axis up here and a y-axis. And since both of my coordinates are negative, it's going to be in quadrant 3. Correct? Okay? So I know that I've got to go over -9 and down 40. So it's going to be a little bit off scale, but that's okay. So I'm going to draw my down here, -40, and my hypotenuse. So theta comes all the way around. But we're only going to work with this part because we need a right triangle in order to write the trig functions. Make sense? We can't write all 6 trig functions unless we have the what? We need the hypotenuse. Okay? How do I find the hypotenuse? Pythagorean theorem. So first, I have to find the missing side. So I'm just going to use Pythagorean theorem. This is equal to 1681 c squared. Who knows the square root of 1681?
64.
Taylor knows it already. It's 41. So my R is 41. So I'm going to label these. What coordinate is this? X or Y? No, it's not. It's X, Y, and R, correct? Okay, now I can write my ratios, my 6 trig functions. So the sine, that's just annoying. It's making me mad. Hang it on. I started it and then I paused it. Okay. Evaluate trig functions. Okay, so I put some steps down here. I'm a step follower. If you want it, you may not need it. It says, number 1, you draw the given angle. Then you drop the terminal side to the x-axis and label the reference angle just like we did here. We labeled the reference angle. Then you label the special right triangle involved. So this has to be 30 degrees or 45 degrees or 60 degrees in order to do these problems. And then you evaluate the trig function based on the special right triangle. Okay? So evaluate negative 225. Negative means it starts here and it goes this way, 180, and then up how much more, do you know? 45. So it's actually going to be right here. If I went all the way around, that's negative 225. And you just told me what this angle will be. What's it going to be? 45. Okay? So now I'm going to make this into a right triangle. All right. Do anybody remember on the unit circle where we're at here? How far back is this? Do you guys remember? Oh, they're still doing it out there, aren't they? It is. If you don't remember, you can pull out your unit circle and take a look. We're right here. The x-coordinate is negative 2 over square root of 2 over 2. So, this is negative. It's going to be kind of ugly, but that's okay. We can do it. If that's that length, then this is going to be what? Because it's isosceles, remember? This is going to be positive because we're going up. How do we get this distance? How do you know it's 1?
We know it's 1 because the other one was square root of 2 over 2.
You could do the math, or you could know that you're working on unit circle, right? And the radius is what? 1. Or you could multiply this by the square root of 2, and you'd end up with 1. Okay? Right? Because it would be 2 divided by 2, which would be 1. So you can either think 45, 45, 90 and get that length, or you can just remember unit circle. Okay. Okay, they need to, this is just annoying. I'll let it go. All right, so now we have to find the sine of negative 225. So what do we do now? What is sine? Opposite over hypotenuse. Okay. So I'm going to do opposite, which is square root of 2 over the hypotenuse. So what's my answer? Square root of 2 over 2. Did we need to go through all that work?
Yes.
Or did you remember on the unit circle that sine is the what coordinate? The y coordinate. But I want you to see the process, okay? That's why we keep doing it. All right. Okay, let's do this one. Cotangent of 5 pi over 3. First of all, let's say, where is that? Well, where is 6 pi over 3? Where's that? It's all the way around. It's 2 pi, isn't it?
Yes.
Right. So 5 pi over 3 is going to be right here, 60 degrees down.
How do you know?
5 pi over 3, if you don't remember, let's take a look. See? Pi over 3 is 60 degrees, so 5 pi over 3 is going to be 60 degrees down. If you want to, I know we can do a shortcut, if that's what you're saying, I know that, yes. Okay,
What's the
On
short
our
version?
test, are you gonna give us like a blank unit circle?
Right.
Part one is to fill it in and part two is to use it?
I think so. I think that's what we did last year.
Oh,
I think so.
Oh, just so it's the answer.
Square root of 3.
What? It is just, it is. You end up simplifying to this.
Oh, I got it. That's actually not hard.
And then you gotta rationalize. It's negative. You gotta rationalize it. Yeah. The 2's cancel out. The -3, square root of 3 is in the denominator, then you gotta rationalize it, and that's why it ends up like that. Okay? It is right. All right, cosine of 150, you ready? That would be all the way over here. That's 30 degrees. That's the reference angle that you gotta use. Okay, so the radius is 1. This is the short side. So how long is that? 1/2. This again is a negative square root of 3 over 2. And then cosine is just what over what? Adjacent, and this one's really easy, over hypotenuse, which is 1. So your answer is this. Okay? All right, we just have 2 application problems and then we're done. And they're quick, I promise.
There's no application. Yeah, there is.
There is application for this. You kick a soccer ball at an initial speed of 46 feet per second.
How do you know that?
They have machines that measure that.
Soccer's not even a real sport. Yeah, exactly.
Stop whining. Your whines are on the video, I'm just saying. Okay. Projected at an angle of 30 degrees. You do not need to memorize this. How far will the ball travel horizontally before hitting the ground? So this is the model that you use for calculating horizontal distance. Okay? V is your initial speed. So if I'm going to plug in what they gave me, what's my initial speed? 46. I got to square that over 32 times the sine of 2 theta. This is theta right here. The projected angle is 30 degrees. So what's double that? So I got to multiply it by the sine of 60 degrees. And all you do is whip it on your calculator, make sure it's in degree mode. And when you do that, you get 57.27 feet.
Is there any time that we have to have it on radians?
I don't remember. It might be. I can't remember. But not yet.
Not yet.
No. Okay, the Navy Pier Ferris wheel in Chicago. How many people have been there?
Where?
The Navy Pier Ferris wheel.
I've been there, but it was too long of a line, so I didn't go on.
Has a diameter of 140 feet. So I kind of drew that in my picture here. And it has a base of 10 feet off the ground. You board a gondola, that's the thing you sit in, on the Ferris wheel, and rotate 150 degrees. So you get on here, and you rotate 158 degrees, and you're stuck here. You're stuck there. Has that ever stopped on you? The Ferris wheel ever stopped? Yeah. All right. Before the wheel temporarily stops, how high above the ground are you when the wheel stops? Guess what? You have the math ability to figure this out now.
No, we don't. Why would you want to? Having a great time on a Ferris wheel. Let me do some
Okay.
math, guys.
So, how far is this reference angle right here? 68 degrees. Okay. Yeah. Oh, I'm just using it as an unknown. You can use y if you want. Yeah. Yeah, thanks for telling me that. Find x. That's our unknown. I'm not using it as an ordered pair. Then add. If you find this distance, then we have to add what? To find out how high we are from the 70 and 10, don't we? So we have to add 80.
What am I trying to figure out here?
How high you are when you stop. Here you are sitting in your gondola.
And you just know
Okay.
you're 158 degrees.
So I just need x.
Okay,
How can I figure that out?
it's easy.
Do I know this distance here?
Yeah, you do.
What is it? 70.
70.
So which trig ratio can I use to find x? Which trig ratio? Opposite, hypotenuse, which trig ratio is that? Sine of 68 degrees equals x over 70. Opposite over hypotenuse. And then this is just a number on your calculator. Basically, you just cross multiply. X equals the sine of 68 degrees times 70. What is that number? I didn't even finish it. What is it?
64.9.
Okay, 64.9. But then I have to add what?
80.
Add 80. And you get 144.9 feet above the ground.
Wow.
Isn't that nifty?
Great that you did that.
Next time